Hello everyone, today we will discuss the topic VSEPR theory for the flipped classroom. Here we will discuss molecular and electronic geometry of different simple molecules and ions. In table you can see number of electron pairs, bond pairs, lone pairs, electron pair arrangement, ballistic representation, molecular geometry and examples. If you have two electron pairs around the central atom and both are the bond pairs, then the electron pair arrangement will be linear, bond angle will be 180 degree angle, for example BeCl2 molecule. And if we have three electron pairs around the central atom and all are bond pairs, then the electron pair arrangement will be trigonal planar, bond angle will be 120 degree angle, and for example we have three molecule. And in trigonal planar electron pair arrangement, if we have two bond pairs and one lone pairs, then the molecular geometry will be bent. For example, SO2 molecule, here you can see the lone pair of electron at one position. And if we have four electron pairs around the central atom and all are bond pairs, then the electron pair arrangement as well as molecular geometry will be tetrahedral and bond angle will be 109.5 degree angle, for example CCl4 molecule. Similarly, if you have tetrahedral arrangement in which three bond pairs and one lone pair present, then the molecular geometry will be trigonal pyramidal, for example NH3 molecule. Here you can see the lone pair at one position. And if we have in tetrahedral electron pair arrangement two bond pairs and two lone pairs, then the molecular geometry will be bent, for example H2O molecule. And if we have five electron pairs around a central atom, then the molecular geometry will be trigonal pyramidal and bond angle. In trigonal bipyramidal we have two axial positions and three equatorial positions, and angle between equatorial and axial position will be 90 degree angle, and in between equatorial positions the angle will be 120 degree angle, for example PCl5. In trigonal bipyramidal structure, the two axial positions are different from three equatorial positions, and equatorial positions occupy larger space. If we in trigonal bipyramidal arrangement four bond pairs and one lone pair present, then the molecular geometry will be seesaw, for example SF4. Here you can see the one lone pair present one of equatorial positions. And if we have three bond pairs and two lone pairs, then the molecular geometry will be T-shaped, and two lone pair of electrons are present at two equatorial positions, for example ClF3 molecule. And if we have in trigonal bipyramidal electron pair arrangement two bond pairs and three lone pairs, then the molecular geometry will be linear, for example XCF2 molecule. Here all the lone pair of electrons will occupy at equatorial positions. Similarly, if we have six electron pairs around a central atom, then the electron pair arrangement as well as molecular geometry will be octahedral, for example SF6 molecule. If we have octahedral electron pair arrangement, five bond pairs and one lone pair, then the molecular geometry will be square pyramidal, for example BRF5, and one lone pair is present one of position. And if we have four bond pairs and two lone pairs in octahedral electron pair arrangement, the molecular geometry will be square planar, for example XCF4 molecule. Here both the lone pair of electrons will occupy at 180 degree angle. Now we will discuss the working method for using VSEPR theory. Here we will take the example of SO4 2 negative ion. First we will draw the ballistic representation of SO4 2 negative ion, and here you can see the central sulfur atom bonded with four oxygen atoms. First we will circle the sulfur atom and we will calculate the valence shell electron, and sulfur is the group 6A element, so the valence electrons 6, and sulfur is covalently bonded with four oxygen atoms. We will count one for each covalent bond, then the total contribution of 4 electrons. Here you can see the 2 oxygen atoms are double bonded with sulfur atom, and we will subtract 2 from the total valence electron count. Then the total valence electron will be 6 plus 4 minus 2, that will be 8. Now we will calculate the number of electron pairs by dividing total valence electron by 2. We will count 4 electron pairs. Now we will see how many of them are bond pairs and lone pairs. Here all the electron pairs are bond pairs. Then according to the molecular VSEPR theory, the molecular structure will be tetrahedral and bond angle will be 109.5 degree angle. And this is the resonating structure of SO4 negative ion. Now many more examples we will discuss in regular class. Thank you.